In this video, I'm going to be presenting our work for WACV 24 entitled JOADAA, which stands for Joint Online Action Detection and Action Anticipation. The contents of this presentation are going to be as so. First, a problem statement where we're going to give a brief introduction to action detection and online action detection, as well as some applications of these tasks. Followed by introducing our proposed solution, where we're going to introduce our proposed architecture, datasets used for evaluation, and results. What is action detection? In simpler words, action detection is finding precise temporal boundaries of action occurring in an entered video. Challenges of these tasks can be co-occurring action as well as long-range temporal dependencies. We already know that it is hard to infer long videos, and so it is even harder to infer long-range temporal dependencies between different actions happening at distant timestamps. In our work, we're going to focus on a more challenging task, which is online action detection, which stands for identifying ongoing actions from streaming videos without access to the future. Online action detection have many applications in our daily life, such as security surveillance, home care, sports analysis, self-driving cars, as well as online danger detection. In this slide, we're going to present some challenges of online action detection. This is an example from the multi-THUMOS datasets. First, we can see that the action run is correlated and related to many actions, such as basketball guard, long jump, soccer penalty, as well as talk to camera. Without access to the future, we cannot have a precise idea on what's going to happen next, and hence it is even harder to infer the ongoing actions. Secondly, the action run is, for example, correlated and related to the action one-handed catch, but still they happen at distant time. Once again, without access to the future information, it is hard to infer these dependencies, and hence it is hard to precisely define the ongoing action. We can resume that the main challenge of online action detection is the fact that we do not have access to the future. So from these limitations comes our motivation for our work. In our work, we add a layer or a block called anticipation prediction layer. This anticipation prediction layer tries to anticipate action before happening. And so we use this prediction and anticipation as a pseudo future information that we concatenate with our past information to have a more precise online action detection. The three main blocks of our work are a past processing layer, which is a transformer encoder, which in blue, and an anticipation prediction block in yellow, and finally the online prediction block, which is in red. We're going to give a more detailed introduction to each block in the following slides. First, the past processing layer, which constitutes of a transformer encoder. The input to this encoder are either long-term past and short-term past, or only the short-term past. Later on, we're going to present ablation studies on both past information, and we're going to see how they can improve or actually harm our predictions. In this layer, we highlight silent and robust frames by leveraging attention mechanism, making our feature more descriptive of previous activities, and hence we have more robust features that describe the past. Secondly, the anticipation prediction layer. The anticipation prediction layer takes two input: learnable queries and the past processed features as input. In fact, each query stands for a time step or a frame in the future. These queries try to learn action that's happening in the future, and each query is related to a certain frame in the future. By adding a positional encoding, we can indicate to the transformer the order of these learnable queries and helps the model relate each query to a certain point in future more precisely. The online action prediction layer now takes as input the past frames that we already processed, the pseudo future that we anticipated, and by mixing these two information, our online prediction block have a more complete view that is constituted of a past, present, and future, and hence it is easier to predict now the ongoing actions. Finally, we add a TCN layer that we concatenate with the output from the decoder used to predict the online action detection. In fact, by adding a TCN layer, we capture the more local information. As we already know, transformers are a good global information extractors. So we we have the intuition to add a TCN layer that can extract a more local information, and by mixing these two information, we can have a more precise predictions. Datasets used for these evaluations are THUMOS, charades, and multi-THUMOS. We use two different kinds of datasets. THUMOS, which is a sparsely annotated datasets where only one action can happen per frame, and charades and multi-THUMOS, which are more complex datasets where we have co-occurrence actions in different frames. In this slide, we present comparison to the state of the art on the task of online action detection with existing methods. We can clearly see that we outperform all the existing methods. We also do a comparison on the task of action anticipation that we use as mid-layer to better perform or improve the online action detection tasks. What we observe that our anticipation also outperform existing methods, and our conclusion is that by jointly doing online action detection and action anticipation, the both tasks help each other improve. As an ablation study, we study the effect of using long-term and short-term past information with respect to using only short-term past. We can clearly notice that our JOADAA method is more robust to using only short-term information. In fact, when the dataset is more complex, our method drops only by 0.1%, whereas the other methods can drop by up to 2% or more. Here we can see some qualitative study. We compare the action anticipation with respect to the TESTRA model on the multi-THUMOS dataset. We can see that our method improve especially on the action that have complex dependencies with other actions. For example, as we saw in the earlier example, the action run has many dependencies and is related to many actions. We can see by adding our pseudo future and anticipation task to the online action detection task, our anticipation improve on such actions. Finally, to conclude, our intuition was to mix action anticipation with online action detection to introduce a pseudo future and to mimic an offline action detection, but still doing online action detection. And we see that by doing so, our method actually improves the online action detection. Thank you.